Hello. Good morning, good afternoon, and good evening. A warm welcome to all of you from around the world. Welcome to this webinar on the Galileo High Accuracy Service. My name is Xin Yi, and I'm from the United Nations Office for Outer Space Affairs. It is my pleasure to be the moderator today. Before we begin, here are a few administrative announcements. First, please switch off your cameras and keep your microphones muted throughout the webinar. Second, please type your questions and comments in the chat. You may do this at any time during the webinar. My colleague Nathalie will be moderating the chat. We will attempt to answer as many questions as possible during the Q&A session at the end of the presentation. Lastly, this webinar is being recorded. The recording will be available on the UNOOSA YouTube channel after the event. Without further ado, let me welcome our trainer today, Mr. Javier Dublas. Javier is a high accuracy and commercial services manager at the EU Agency for the Space Program, EUSPA, and he leads the implementation of the Galileo, HAS, and CAS services. Javier, over to you, please. Javier, I believe you're muted.
You should be hearing me now.
Yes, I can hear you very clearly. Thank you.
So, good morning, good afternoon, good evening to everyone. As I was saying, it is my pleasure to be here today with all of you to provide an overview on the Galileo High Accuracy Service. Let me briefly introduce myself after the warm welcome from Xin Yi. I'm working for the EU Agency for the Space Program, EUSPA. This is an European agency from the European Commission, delegated with responsibility on the exploitation of the GNSS, of the space programs, and in particular of the GNSS programs, and tasked with the services provision of those services based on these GNSS programs, as is the case for the Galileo Global Navigation Satellite System, on which basis the high accuracy service is provided. Now, if you let me, I will switch off my camera in case it can improve the connectivity, and I will share my screen so that we can jump into the slideshow. So I hope you can all see the presentation now. So as said, I will provide you with an overview about the Galileo High Accuracy Service, starting by addressing the current Galileo Services Portfolio, describing the services that are currently provided by Galileo, in which context the Galileo High Accuracy Service was recently declared operational. Then we will spend some time in addressing the rationale behind the Galileo High Accuracy Service. Why the European Union invested in the development of such a service, and what are the reasons and the drivers for such implementation. Later on, we will address the basics. What is it? What are the components of this high accuracy service in terms of structure and technical products that are being distributed, broadcast to the users? To finally address the user segment, expand a few slides in looking at the Galileo High Accuracy Service users and the user segment, how it is built on, what are the applications, the target markets, and the current developments in the user side. And finally, I will try to provide you a prospect view, a forward-looking view on what should be coming next. What are the expected evolutions on this service, and what are our expectations on the next months, years to come when it comes to the Galileo High Accuracy Service. So let's start. with the Galileo Services Portfolio to put the Galileo High Accuracy Service into context. First, it is highly relevant to underscore one of the principles driving the EU space programs, and in particular the GNSS programs of the European Union, as described and defined in the law, in the European Space Regulation that you can see referred to in the slide. The user needs, the users are at the very core, at the very center of our program conception and the way it is defined. All these services or the system evolutions are conceived to meet the user demand, to satisfy the user needs. To this extent, USPA is systematically and regularly monitoring these needs as the Galileo services provider, and is organizing specific fora to gather these needs and to analyze those. As I can mention, the European Space Week, which this year will be organized between the 7th and the 9th of November, and the associated user consultation platform, where we are actually interfacing with the users in different markets to try and gather their needs, their expectations, and their feedback about the services being provided. And what do we do with those? We are setting up, we're implementing an engineering process which translates these needs into the very requirements, what we call the services baseline, the requirements we are making applicable to the exploitation, the service provision, the operations of every system and service, to ensure that we can meet the expectations of the user community, of the European citizens, and globally of the potential users all around the world. And this being structured in all necessary categories in terms of performance monitoring, services delivery, user interfaces, operability, maintainability, and system related requirements. A holistic approach to ensure that the services we deliver are as close as possible to the user needs, as it is the case for the high accuracy service, as I will try to highlight in the slides to come. So now let's take a closer look at the service portfolio of Galileo. Today, Galileo is delivering 4 different services. The so-called open service, which is enabling a free of access positioning service based on the signals broadcast by the Galileo constellation. Then the public regulated service, so-called PRS, which aims at supporting governmental users in support to sensitive applications requiring a higher level of service continuity and therefore a higher level of protection. The Galileo SAR, the contribution of Galileo to the COSPAS SAR-SAT international system to support search and rescue, to support the location basically of people in distress, equipped with a so-called SAR beacon, and then the last in the club, the high accuracy service that was declared operational in the 24th of January this year, that we will be analyzing along the session today. But beyond this, and taking a look to what we can expect in terms of short, mid-term evolutions and long-term evolutions, this is not the end of it. Galileo and the European Union is working hard to develop new services, new evolutions. As you see in the screen, beyond the last service declared, the high accuracy service, we are already intensively working, and I will address this in a dedicated slide, in the development of the so-called Open Service Navigation Message Authentication Service, or SNMA, which is aiming at enabling the authentication of the navigation data broadcast by the Galileo satellites. And meanwhile, and in parallel, we are progressing at earlier phases with two more services, the commercial authentication service, which again will enable an authentication capability, which based on the authentication of the E6C pilot component, the ranging signal being broadcast by the Galileo satellites in this frequency, plus the authentication of the navigation data enabled by USNMA will enable for the first time ever an authenticated PVT based on the Galileo system. And then let me mention the emergency warning service, which is another service under development aiming at enabling the on-demand broadcast of emergency alerts to population in a target area based in the capabilities of the Galileo system. So all in all, 4 different services of Galileo, but 3 more in the pipeline, specifically in the short term when it comes to OSNMA, and still more to come. So now about high accuracy and OSNMA, just a snapshot view on what the roadmap is for those two services. I will not stop much on high accuracy as we will address the related elements later on. The high accuracy service implementation started a few years ago, but when it comes to the implementation phases, started with a testing phase back in 2019, which was followed by the initial service declared already in the beginning of 23, whereas OSNMA is following a similar approach that should be uh, coming to a specific declaration before the end of this year. So as you see, intense work at Galileo program level, parallelizing the implementation of different features, as said, driven by the user needs. So when it comes to SNMA, just let me mention that even if the service is not yet declared, we're talking about a signal that is being broadcast as we speak and is enabling the first ever authentication test signal provided by a global navigation satellite system that is being enabled by Galileo uh, today and since November 21, and providing very good availability even during the test phase, the public observation, the so-called public observation, and enabling the authentication of the Galileo navigation data. And then let's take a forward-looking view even beyond the implementation of these services I've mentioned. What are we working on? What are the future evolutions that we could expect? Well, in this sense, again, and under the same principles, we're working towards enabling more ambitious evolutions in terms of new services and evolution of the existing ones towards multi-frequency, multi-purpose authentication capabilities in the different frequencies and support to emerging applications as autonomous navigation, positioning and Internet of Things, safety critical liability critical transport, and support to critical infrastructure related applications. And all this with the complexity and with the commitment of ensuring the continuity of the existing services, the backward compatibility to those so that there is no interruption and the users already benefiting from the existing services, they can continue using those and capitalizing on the lessons learned that we're taking on a regular basis. And these are done in the frame of what we call the Galileo second generation evolutions, which should be implemented in the years to come. So how does this translate into the service portfolio? This service portfolio that we described before with the current services and the incoming ones. So you can see that this service portfolio grows in the number of services and in the complexity of those. And I will mention very briefly improvements within the Galileo Open Service that will complement the current navigation positioning service with a specific timing service, with the contribution and the commitment in the contribution to safety of life applications, specifically in aviation, improved performance for our public regulated service, introduction of additional service levels for the Galileo SAR with on-demand remote beacon activation and advanced capabilities as two-way communication distress positioning service, the introduction and the evolution of the emergency warning service, the evolution from the OSNMA service that I mentioned to a full open service authentication capability, which will enable the authentication of the open service frequencies, E1, E5, both in terms of navigation and ranging, and the same capability in the E6 frequency, evolving the commercial authentication service to the signal authentication service, the evolution towards better performance of the high accuracy service, and the introduction of the so-called contribution to iono prediction, the CIP, which will support the existing iono prediction ecosystem with some capabilities supported by Galileo. All in all, an intense work to expand the current portfolio and to deliver a wide range of capabilities as demanded by the different user communities. All of this with a key interface towards the user community, which is our GNSS Service Center, the GSC, in which web page you can find all related documentation, performance and regular reporting, service information, as well as progressively indications on the evolutions to come. So I invite you to register and check all this information. And now let me step into the essence of the webinar. Let me address the Galileo High Accuracy Service. Why the European Union invested in developing such service, such capability. So this started back in even before 2018 with some initial studies which materialized in the decision from the Union to provide the service for free with a target performance of enabling 20 centimeters positioning accuracy uh, in the timelines we refer to. But why? Why this investment? What was the reason behind? Well, we believe that first, it follows a natural trend. Back in the 90s, with the introduction of GPS as the first global constellation, there was a positioning accuracy around in the range of hundreds of meters of error linked to the so-called selective availability of GPS, which approximately a decade after was reduced down to tens of meters once the selective availability was removed. And uh, one decade after, with the introduction of new constellations, and in particular Galileo and others, and the evolution of GPS was further reduced to the range of meter, 1 meter, few meters error. Therefore, declaring the and deploying the high accuracy service, which enables one order of magnitude less, a accuracy down to a decimeter level, follows clearly a natural trend driven by the market and the natural trend in the improvement of the accuracy, positioning accuracy by the GNSS systems. Moreover, we consider this is part of an existing ecosystem. The provision of these PPP corrections, the PPP technology is an existing one. It is not an invention in the frame of Galileo. It is an existing technology, but still this high accuracy service is considered, we consider it one of its kind, because even if there are existing PPP services There are some which are provided on a commercial basis, whereas the high accuracy service is free of charge. There are organizations which are providing such services on a free basis, but these are either provided on a regional basis, as the Japanese QZSS system, the developments in Australia and New Zealand ongoing, the capabilities of the Chinese constellation, or are provided by research institutions and universities, and therefore not warranted with no commitment in terms of performance or 24/7 operations. Whereas the high accuracy service is the first service ever provided by a global constellation with a committed performance operated 24/7 and on a free of charge basis. Most importantly, and as I mentioned before, consistently with the principles applied to the definition of the Galileo services, it meets the user demands. When it comes to positioning accuracy, there's a wide range of applications demanding such accuracy. And most importantly, beyond the scenarios that we can think of at a first glance, there are huge regions of the globe which are not served by such level of accurate positioning, where a service like this, free of charge and broadcast on a global basis, we do believe it can make a difference. Um, and furthermore, it's compatible with the existing commercial applications. And we do believe it matches with the market demand, as it leaves room for the commercial applications, and it leaves room for innovation to reduce the accuracy down to centimeter, millimeter level, to provide integrity and additional features which are not enabled by the Galileo High Accuracy Service. And as one more element to be considered, it was provided and it was designed to make use of the existing Galileo system infrastructure, therefore with a high cost benefit rate. So making use of the existing infrastructure, of the existing bandwidth to ensure we can broadcast these products for the benefit of different communities. So now let's take a closer look, even if at high level, at what is this service all about, how its infrastructure look like. So basically the service is enabling the broadcast of precise corrections, what we call PPP corrections, for the satellite orbits, clocks, and signal biases, so that by correcting those, we can come up with a high accurate positioning. These corrections are broadcast, are distributed via two different channels. On the one hand, the Galileo signal in space in the E6P signal component, and second, as a complementary channel via internet. On the grounds and based on these corrections, the typical accuracy that can be obtained, it's at decimeter level, after applying these corrections and processing these corrections by a PPP, user algorithm at receiver level. And these corrections are broadcast, are distributed on a global basis and free of charge. Let me clarify that when we refer to almost global, we're referring to the service map and the committed level of performance that is described in the Galileo High Accuracy documentation, where there are some regions of the globe where this performance could not be characterized, but still I can confirm the corrections are broadcast on a global basis all around the globe and can be received from anywhere in the globe. If you see in the graph, just to give you in a snapshot the potential, the flavor and the potential of this service, we can see in the graph a graph, a figure displaying the GNSS only positioning error as enabled by Galileo and GPS satellites uh, that, as you see, spans in the range of meter error. And you can see the green spot at the very center with the Galileo High Accuracy Service enabled positioning, where the error is reduced 1 order of magnitude down to decimeter level. So now when it comes to infrastructure, let me briefly summarize. As I said before, this service is delivered on the basis of the existing Galileo infrastructure. Therefore, now based on 15 Galileo sensor stations distributed, as you see in the map around the globe, which are collecting data, observations from the Galileo and GPS satellites. This data is distributed to the so-called high accuracy data generator, the infrastructure deployed in our GNSS service center in Madrid, where the corrections are computed and are distributed to our control centers that via our uplink stations are transmitted to the satellites for the broadcast of the signal and the associated corrections. And in parallel, these corrections are distributed via internet through our GNSS service center. Then on top of this, the number of activities that we do beyond the operation of the infrastructure. We work on the very service delivery, services development and validation, operations, maintenance, security accreditation, and overall service provision with the support of the European Space Agency, which is acting as the system design authority and supporting on the specification and development of the core infrastructure of Galileo. So now let me go back to the service area that I was mentioning before, uh, as defined in our high accuracy service definition document. This document you see on the left-hand side of the slide that you can download from our GNSS Service Center. This is a service area. As I mentioned before, there are two areas in dark blue which are excluded from the service commitment. This meaning that in those areas, given the nature of our sensor station network, we couldn't compute the performances that can be warranted over time in those areas. But again, and as confirmed by numerous assessments and published papers, the corrections are actually being broadcast in this area, are received in these areas as broadcast by the Galileo constellation and enable the processing of the corrections and the improvement of the positioning accuracy. And now that we talk about performances, let me show you a slide indicating clearly two elements. First, USPA's Galileo service provider is reporting on a regular basis and publishing the performance reports for the different Galileo services in the GSC. And obviously, we're doing the same for the Galileo High Accuracy Service. You can find the two quarterly performance reports that we have published already, where you could confirm that the minimum performance levels have been fulfilled since the day of the declaration consistently up to now. You see in the screen, and I won't step into the details of every performance level, but we have been systematically meeting these performance levels. And the performances have been stable and good overall these first 6 months, 7 months of life for this service. But beyond this, let me show you a graph displaying the actual performances as obtained by one of our receivers installed in Rome, where you can see once again the order of magnitude of the GNSS only solutions. So you can see in blue the performances, the positioning performances in the both horizontal and vertical planes obtained based on the Galileo or GPS only positioning. Whereas in orange, you can see the positioning performance enabled by the Galileo High Accuracy after applying the corrections to these two constellations. So a tremendous accuracy improvement both in the horizontal and in the vertical domain being systematically and consistently enabled on the grounds of this service. Now, if we move to the user domain, the Galileo High Accuracy users and applications, let me sketch what are the user requirements, what are the user capabilities required to benefit from the Galileo High Accuracy Service. So, as I mentioned, there are two dissemination channels for the Galileo High Accuracy Service, either the E6B signal in space or the internet distribution of the Galileo corrections. So any user that wants to benefit from the Galileo High Accuracy Service needs, on the one hand, to have a receiver that can either receive and process the GNSS signals as enabled by Galileo or GPS, and a receiver able to receive and decode the has corrections broadcast in the 6B signal component, or a receiver able to receive and decode these corrections as distributed in an entry format, RTCM entry format via internet. So based on this receiver and the implementation of the PPP algorithm on it, a user can first receive and decode and process the GNSS signals from either Galileo or GPS. Second, receive and decode the high accuracy corrections, either from the signal in space or via internet, and then by applying a PPP algorithm, coming up with an improved positioning with an accuracy down to decimeter level. And what was the work done in the user segment? Because I spent some time in addressing the rationale for this development. What is the architecture for this service? Um, what are the performances? But what was the effort done in the user domain to ensure that once this service was declared available, it could be used? Well, systematically, as I said, USPA is surveying the user needs, is interfacing with the different user communities. And in this case, let me highlight the specific Galileo High Accuracy Service survey that we launched between 2020 and 2021, where we tried to gather updated feedback and inputs in view of the initial service to come. We analyzed the requirements from different user communities, the expected functionalities and performance, and the way we could validate and involve, engage the different communities. And I'm just highlighting a few features. Uh, the accuracy levels were identified as a barrier for certain user communities. So the demand on higher accuracy was clear. The demand for reduced convergence times was made clear. It was identified the need to enable E6 capable receivers. And there was a lot of appetite in terms of the worldwide coverage free of charge basis for this service and the independence from other networks as the communication networks. What about the potential of this service? Well, in terms of target applications, there's a tremendous range of different applications that could benefit from such a service. We can mention as the main ones, but not the only ones, agriculture in terms of automated machinery, precise farming, of course, mapping, surveying, for transport, aviation, and drones for specific applications, consumer solutions, mass market applications, maritime transport, rail, road, but beyond those, a lot more. And we expect you all to drive innovation based on this service to enable some other applications that we didn't even think of. Overall, the most evident impact is in terms of transport and mobility. We can mention, because there are already ongoing implementations in terms of precision agriculture and evolutions for the associated applications, but as well maritime and other transport applications, which are actually testing the potential of the high accuracy service for certain level of applications in certain scenarios. So now, what did we do to ensure the readiness of such applications, such devices? Did we wait for this service to be declared? Not at all. The European Union has been supporting the early development of prototype receivers since many years now. There have been different programs launched in which frame there has been European funding to ensure and to support the development of prototype receivers. We can mention the so-called fundamental elements framework, where there were at least even more now, 9 different projects related to high accuracy. In the frame of the so-called Horizon 2020 project framework, there were 5 more projects, and beyond, we procured the development of a specific user terminal, implementing a reference algorithm, an algorithm at user level, on which basis we validated the service and we confirmed the level of performance that we can ensure. And moreover, and again, let me underscore that this is fully consistent with the spirit and the principles I mentioned in the beginning of the presentation. We involved key stakeholders, interested parties in the early testing of this service back in 2021 and last year as well. So whenever we enabled the signaling space, we ensured within the appropriate framework that there were interested parties and users having access to the corresponding ICD, to the corresponding documentation, and they could develop their capabilities and test well in advance the potential of this service so that they could arrive ready at the point in which we would declare the service, as we did in January this year. And in this sense, we can confirm there are already receivers E6 capable and E1, E5 as well for the Galileo Open Service signals. There are receivers available, and of course there are internet connected receivers available in such a way that the high accuracy service, the implementation, the use of this service is more accessible, and we expect more and more wider number, a higher number of commercial has-enabled receivers to be available on the market. With the information we have today, I can mention, as you see in the screen, at least six different manufacturers in different market segments, which are already commercializing has-enabled receivers that you could get access to, plus confirmed plans from other key receiver manufacturers worldwide. As you see in the screen, we're talking about key players uh, developing such capabilities, and just after 7 months of the initial service declaration. So again, a holistic approach that translated in the availability of the service uh, and the increasing availability of receivers in the market in a synchronized manner. So now, what comes next? Once we have got a flavor on what this service is all about, what are the products that are broadcast, what is the level of performance that we enable in the market segment, the developments and the work done and the number of receivers available, the type of applications that can benefit from that. What could anyone expect from this service in the years to come? Well, first of all, in the short term, the main target, all the efforts are ongoing to ensure the service is used. We encourage you to use it. We need the user segment to be developed. We're supporting and we will continue supporting the development of has-enabled receivers and the implementation of research and development actions so that innovation is enabled on the basis of this service. More and different applications are developed to benefit from its capabilities. And finally, and this is a very important element indeed that I want to highlight, and that talks about the holistic approach we implemented, the integral assessment that we did, the availability of the reference algorithm. I mentioned before that any user willing to benefit from this service, it needs a receiver capable of getting the corrections, but furthermore, with a PPP algorithm implemented. There have been PPP developments since many years. There are algorithms available in the market as developed by different companies, but the European Union and the Galileo program will make available a reference algorithm on a free of charge basis to any interested party in the coming months. So that it's not only that we will be broadcasting free of charge globally these corrections, but we will enable a reference algorithm for those entities that do not have their own means to for such a development and can benefit from a cheaper implementation, a faster implementation based on this reference algorithm. And beyond, and looking at the so-called phase two, we're intensively working because this is not the end. We expect this is just the beginning. We're working towards the evolution of this service to come up with increased performance at global level. So we're looking at increasing the accuracy enabled by this initial service by a wider network of stations and enabling a faster positioning, a shorter convergence, and adding key functionalities as the authentication of the high accuracy service corrections and the characterization of the error, which could be a very relevant input for a potential safety of life application integrity processing at user level. So again, short-term perspective, mid-long-term perspective, and end-to-end approach to make the access to the service closer to the users all over the world. And finally, let me just, because sometimes an actual demonstration speaks by itself, let me show you a video uh, that illustrates the potential of this service. So I hope you can see it.
Hi, Javier.
Yeah.
You need to switch on share computer sound.
Okay, so sorry about that. Let me share again. Okay, now I hope it's okay. Let me try again. Apologies for the hiccup. I hope it is okay now. So basically, this video is showing you a testing activity, a demonstration that we performed with the Joint Research Center in Italy, where we installed within a van a GNSS antenna together with 3 different receivers: a smartphone, a high-end automotive receiver, and our high accuracy service user terminal. As you see in the screen, the yellow spots show the positioning provided by a smartphone with errors in the range of a few meters, almost 10 meters, a high-end automotive receiver with the blue dots with errors ranging in the order of 1 meter, and then the red spots, which are showing the high accuracy service positioning that, as you see, are hitting the track every time with errors in the range of 30 centimeters during the early testing phases. So based on this, you can imagine the potential of such a service. It is true that with this scale, we cannot perceive the actual and precise range of the errors, but we're talking about an order of magnitude in a test with a car, with a van, and this proves and shows the huge potential that I was mentioning for transport applications, but beyond this, and this even done, as said, within the early phases of the testing. On these grounds, we do expect this service to support a wide range of applications in many domains, and I hope this video helped you all to taste the potential of this service. And now finally, before I finish and we give you the floor for questions, let me provide a tribute to the people that made this all possible. This the Galileo initiative as one of the EU flagship programs, but specifically the service is the result of international cooperation, is the result of the effort of many people, many different companies in different countries all over Europe and beyond, involving international partners. And it's the result of a truly cooperative spirit. And that is why this makes it even more relevant. With this collective effort, we enabled a service that is now available free of charge to support any country, any people around the world, and is here to stay. Thank you very much.
Thank you very much, Javier. Been moderating the chat while you were presenting. So while the questions are coming in, I just have one in the meantime for you, please. You were mentioning that there will be a precise point positioning algorithm made available in a few months. Could you please let us know how people could get access? Like, where can they find more information? Where can they find the data? Thank you.
Sure. First of all, I would invite everyone to register in our GNSS Service Center website so that they can get the news and alerts about the availability of this element and any other from those that we're progressively delivering and making available. When it comes to the reference algorithm, indeed, it is the intention to make it available in terms of first, a document with a processing model description supported by some test vectors. These are certain files which can enable the interested party to verify that the implementation of it is correct. And third, a specific implementation of the algorithm that can support the users to implement these elements are planned to be available before the end of the year and will be accessible via a free of charge licensing scheme, and all the information will be made available via the GNSS Service Center. So stay tuned, get registered, and we will keep you informed.
Okay, thank you very much. So through the GNSS Service Center, I've put the link in the chat earlier and I will add it again. We also were asked if you could explain, are there guidelines available for the use of the high accuracy service through the internet? Is it also something available, like guidelines maybe available at the service center?
I can confirm two elements, and I appreciate you make this question precisely today, because first, the users are welcome to register to our internet data distribution service via the GSC. Once they register, they get access to the service and they will receive the applicable documentation, in particular the interface, the ICD, the interface control document, where they will find the format of the corrections distributed via internet, the content of these corrections, and the necessary data to get connected. But furthermore, today we have enabled some test vectors related and some associated material guidance to ensure that when these corrections are processed, are correctly decoded from the messages that are broadcast via internet. So we already enabled this material that can be requested via a form in the website. If you access to the website, and maybe let me try and see if I could display it for you. Hope you can see my screen.
Yes, we do. Thank you.
So you see has IDD test vectors. So we published right today the IDD test vectors and supporting material. You can access through our GNSS Service Center website and request, click in the associated form, fill it in, and request access to this material. So the answer in a nutshell is yes. And just today, we made this available in terms of internet data distribution access.
Okay, great. Thank you very much. Another question, we are using, of course, GNSS services on Earth, but it's also possible to use GNSS for spacecraft in orbit. So we had a question of whether it's possible to use a high accuracy service for orbit determination.
The answer is not straightforward, but in a nutshell, the answer would be yes. Let me show one of the slides I presented, where we can see this manufacturer Beyond Gravity, which has implemented has in these two receivers, which are installed in satellites, in particular in one of the European Space Agency missions, in which the positioning based on these corrections is tested. So the answer is yes. It's not an absolute yes for all and every mission in all and every scenario, but this can be used, and we are supporting the assessment in the use of these corrections to determine up to which range this can be used.
Okay, thanks a lot. So definitely a lot of useful information via the service center. I mean, this is more technical training, but we had somebody who was wondering if you can say a few words about the legal issues. Are there any legal aspects linked to the implementation of the high accuracy service?
I'm not sure about let's say the precise intention of the question. I can say that indeed, it is not specific from high accuracy service, but in general, whenever there is a new service being provided by a new actor in a given market, this can create concerns on the current players within this market. What our market studies indicate is that the creation of value in existing markets compensates by far the potential, let's say, impact in the current scenario. And the evidence of this in the case of the high accuracy service is that existing providers, commercial providers, are already implementing and using, assessing the use of the Galileo High Accuracy as one more input element for their services. So I can confirm that the definition of this service created some concerns in the past, but legally speaking, there's no issue at the moment. The service, from the obvious, can be used and is free of charge, available worldwide. And when it comes to our interactions with existing players, I can say that there is a smooth and continuous communication with the key players in the market, and that the declaration of this service has been welcomed by the community. I had the opportunity last week to participate in the ION GNSS conference in Denver, and I can confirm that the overall feedback we received from key players, Hemisphere, Kongsberg, Broadcom, Google, and many international companies is way positive.
Okay, thank you very much. So then again, I would invite all our attendees to consult the Galileo Service Center, lots of information over there. And then I'll just hand back to my colleague to wrap up. Thank you very much.
Thank you.
Thank you, Natalie, and thank you to all our participants for the questions. We hope that you have benefited from today's training, and do check out our webpage for other trainings covering a wide range of topics, from Earth observation data processing to business strategies to become a space entrepreneur. And the link will be provided in the chat. So in the next session, on Galileo High Accuracy Service will be conducted in Spanish and starts at 4:15 p.m. CEST, which is 15 minutes from now. So do stay tuned if you are interested. So once again, thank you so much for your participation and have a good day.